In this video we're going to look at shape and space, and we're going to concentrate on two-dimensional figures. Now, 2 dimensions means it's something you can draw. There you go, let me try and draw something. There you go. There's a self-portrait. So you can draw that on a piece of paper. It's got width, I guess. It's got width this way, and it's got height, and that's it. Just 2 dimensions. Compare that to, say, these. What we were throwing these cubes around, if you remember. This is 3 dimensions. It's got width, height, and then depth, if you want to call it that. Now you have a picture of me. I exist in 3 dimensions. But for this video, we're going to focus on 2-dimensional shapes. I've just written all the names of the shapes you have to be able to recognize. So what I'm going to do is take my camera outside and see if I can find these shapes outside. So what I want you to do is stop the tape, copy these names onto pieces of paper, then go outside and see if you can find the shapes and then stick or attach the names to the correct shapes. This is a parallelogram which I've constructed out of, let's see how many triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equilateral triangles. Now we're going to use this to make something which is quite interesting, I think. So the first part of our making of this, if you like, is to score along those lines so we can bend the triangles easily. So what I mean is, put your ruler on the line like that, then take your compass point and lightly scrape along the line. Not too hard, otherwise you'll cut the triangle off. So why we're doing this is so that it now, as you can see, it bends much easier now along that line. So the first thing I want you to do is score all of the lines and then make sure that it folds nicely both ways along each line. So just stop the tape until you've done that. Now, what you've now got to do is put numbers on your parallelogram like I have done. And there's a reason why they are upside down or on the side, as you'll see when we make our new shape. So if you can stop the tape now, put your parallelogram in the same position as mine and then number them as I have done. Now, what you must now do is just turn it straight over. Alright, turn it straight over as I'm doing now. There you go. And that's what we need on the other side. So stop the tape and copy those numbers and the two letters A and B onto your parallelogram. Okay, now we're going to fold it. Let me show you how we fold it. So, like this. And I want you to fold it like that. Then turn it over like that. Okay. Fold this one like that. And then whip that over like that. So now I've got all the ones on one side. If I turn it over, what I'm now going to do is glue triangle A to triangle B. So I'll just get my Pritt. There you go. So I'll just put a little bit of Pritt on A, a little bit of Pritt on B, then I'm going to stick them together like that. Okay, so I now have a new shape. And what's the name of this? Well, it's got 6 sides, I think you can see. 1, 2, 3, 4, 5, 6 sides, made up of 6 equilateral triangles, and we call this new shape a hexagon. Now, because all the sides are equal, this is an example of a regular shape. So if you've got a shape which has got equal sides, like in this case, or hexagon, then you'll have a regular hexagon. Now what we are going to do is flex this hexagon like this. So hold a corner, doesn't matter where you start, and pinch it, and then try and fold this one down and open it out, and see if it will open out. No. Now keep moving around. Push it down, pinch it. No, keep moving around. Aha, looks like it'll open here. And then carefully open it. And now you've got sides 3 and 2. Let's see if we can get the side 1 back. Oh, there it is. Keep flexing. See what have we got now? 1 and 3. Where's 2 gone? Not working there. There it is. Now you've got 2 and 1. So this is an example of a tri-hexa-flexagon. Tri because it's got 3 faces. Face 1, face 2 and face 3. Flexor because we flex it and bend it. And hexa because it's got 6 sides. So a tri-hexa-flexagon.